All right, so this next section is called applying the quadratic function to geometry, but really this means can we apply the quadratic function to some kind of situation when we have some kind of constraint here. And you'll see what I mean by constraints. All right, so here's the situation. A parking area is to be constructed adjacent, so next to a road. The developer has purchased 340 feet of fencing, determined dimensions for the parking lot that would maximize the area, then find the maximum area. So right away, it may not be completely clear that we need a quadratic function to do this, but notice the word maximize. Right? We want to maximize the area. Okay, so when you think about different types of functions with a maximum, well, a parabola has one true maximum, so maybe we can use that to help. But first things first, we're going to draw a picture. That's always the first step. Okay. All right, so the thing that we were drawing a parking lot, but it's beside a road. So this is our road, and then next to it we have our parking lot. Okay, and so we want to maximize the area, so this space. So it would be nice if we had some variables to be using. Maybe we could talk about this side and this side. So maybe this will be x, this would be y, and also this is the same, it would be x again. All right, so we're not going to include the road over here because if we're trying to like box out our parking lot, we're not going to include the road. All right, so let's go ahead and talk about what these variables are. X is our length or width of the parking lot. And Y is the opposite, so the width of the parking lot. Okay, and so our goal with this problem is to maximize area. All right, well, it would be nice if we knew what area actually was. So can we use what we have here to write an equation for the area of this parking area or parking lot? So area is always length times width. So we have our x times y should give us the area. Okay, so this is good. We know our area. We need to figure out how to maximize it. Notice we have two variables here, x and y. We're not used to solving things with multiple variables. So our goal here is to be able to rewrite our area in terms of just one variable. So our step number 2 is we're going to use additional information to write a function for area with only one variable. All right, so this is important. We only know how to work with one variable, so we need to be able to write this in terms of only either x or just y. So what additional information is there? Well, the road is going to be fenced, and the developer purchased 340 feet of fencing. Well, that's a constraint. We can use that. All of these side lengths, not including the road, should add up to be 340 feet. So we can write out an equation for that. So 340 would be this side, and this one. So that means we have 2x and 1y. So basically this is the perimeter of the three sides of our parking lot. Okay, notice we can solve for any variable. Let's solve for y. It's a little easier to do. So we'll have 340 minus 2x equals y. Perfect. All right, so now that we've solved one in terms of the other, we can go back to what we are maximizing. So back to the original problem. All right, so what are we maximizing here? Area, which we determined to be x times y based on our picture. But now we found a way to rewrite y, right? Instead of using y, let's use 340 minus 2x, right? So we wrote y in terms of x for this purpose. Okay. And then I'm going to distribute this x, and you'll see where we're going here. All right, what kind of function is this? It's a square, quadratic function, which means this is the picture of a parabola. All right, so I'm going to go to the top of my page and use the other side. All right, so what we just found down there is that A is, and if you want to reorder this, you can, or you can leave it like this. A is negative 2x squared plus 340x. What do we know about this parabola? Does it face up or face down? Well, it opens down, which means at the top, we're going to get a maximum value. All right, so let's stop and think about what this is telling us. Okay, so we're trying to maximize the area of this parking lot. We've written an equation, so this represents every area for different values of x. And in order to find the maximum, we need to find when is this area the biggest. Well, since it's a parabola, it's going to be biggest at the vertex. So let's find the vertex. Okay, so we have a shortcut now. So for the x value of our vertex, instead of having to complete the square here, we have a formula. Negative b over 2a should tell us the x value of our vertex. All right, so our b here is 340. And our a is negative 2. All right, so that simplifies to 85. So the x value that makes the area the biggest is 85. All right, and so let's figure out what that area would actually be. We can plug in 85 into our area. All right, and so this should be 14,450. I'll do the units later. 14,450 is our maximum area. Okay. All right. So let's go. So I'll write out the vertex so we know what we just found. Our vertex, x value 85, y value 14,450. All right, and then finally, let's answer our question. So the question is, determine the dimensions for the parking lot that would maximize the area. So what do we mean by dimensions? Well, those are the side lengths of our rectangle or our parking lot. So dimensions would be our length, which is our x. So the length that would maximize, we already found it. X is 85. I'm going to put my units here. We're using feet. How do we figure out the width? Well, that's y. How do we figure out what this y is here if we know x? Well, we did some work down here, and we solved for y in terms of x, so we can find it. So y is 340 minus 2 times 85. All right, if I'm not mistaken, this gives me 170 feet as our dimensions. So we get length is 85, width is 170. So that's part of the answer. The last part of the question is find the maximum area. Well, we found that by plugging in the maximum x value into our area function. It's that 14,000 number. And so remember, area is length times width, so we're going to have to square these dimensions. Feet squared. All right, so make sure you're able to determine a quadratic function when we have a description and apply it to things like rectangles. All right, let me know if you have questions in class.